So we're going to do a couple of examples. These are kind of problems that I will expect you to be able to do, say, on a test. So we're directed to find a delta. Notice I'm saying a delta. It's not going to be unique, but we're going to find a delta for a given epsilon. So in this first problem, I'm going to tell you that we're going to take the limit as x approaches 2 of, here's our function, 3x minus 2. I'm telling you on this one what the limit is. I won't always do that. But more importantly, I'm telling you what the epsilon is. I'm giving you an actual number for epsilon. In the next example, I'm going to not specify what epsilon is, which I think makes it a little bit more challenging. Now, the directions are a bit to sort through, so I'm going to read them as I write them here. So I want you to find delta so that, and this will be given to you on the test, so you don't have to memorize this, so that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus c is less than delta. So now the challenge is to figure out how to use this. So again, this part right here is going to be given to you. Now what we're going to do is we're going to start with this part first. So we're going to say, well, the f of x, that is our 3x minus 2. And we want to go minus L, and the limit is that 4, so I'm going to say minus 4 in absolute value is less than, and in this example, I'm giving you a number for epsilon, so we're going to call that 0.01. Now, our goal is to get to here. So what we want to do is get to x minus c. So just so we remember where we're going, we have an idea of where we're going. RC in this particular example is 2, which means what we want to get to is just the x minus 2 in absolute value. If we can isolate that x minus 2 inside the absolute value, whatever's on the other side is going to be our delta. Okay, so armed with that, we come back to the absolute value of 3x minus 2 minus 4. Well, we can combine the minus 2 minus 4 to get minus 6. And then we can factor out that 3. And this is good news because now we can see this x minus 2 emerging. Now we can pull a positive number outside of an absolute value, and that will leave us our x minus 2 inside the absolute value. And then we can divide the 3 over and get 0.01 over 3. Now, on an AP exam, this would be great, and they would be totally fine with this. I can't live with that, so what I'm going to hope is that you can multiply top and bottom by 100 so that we don't have a decimal in a fraction, and so that will become 1 over 300. So a better answer is going to be the absolute value of x minus 2 is less than 1 over 300. And so our delta is 1 over 300. Now, big picture, let's just see if we can imagine what's going on here. So our original function, the 3x minus 2 function, is going to be some straight line, and it's going to have slope 3 and y-intercept negative 2. So there's our function. And we said our value of c was 2. So, and this is not going to be drawn to scale, but here's our x value. And we claimed that that y value was going to be 4. And so what we have said is that if you choose an epsilon to be 0.01, that is, if we want all of our y values to be within 0.01 of 4, then what we have claimed is that we must choose an epsilon, that is this distance here, to be 1/300th, or we could go less. So as long as we stay within 1/300th of x equals 2, all of those x values, after we plug them into our function, will give us y values within 0.01 of 4. Okay, let's do a new screen, and we're going to see the second kind of example that we might have to do. So in this one, we're going to start with the limit as x approaches, I'm going to say negative 3 of x squared, and then I want you to show for all epsilon greater than 0, there exists, that's supposed to be an S, delta such that, and here again is how I'm going to give this to you, the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus C is less than delta. Okay, now a few more twists on this. I didn't tell you what the L is, but that's not a big deal because we can direct substitute the negative 3 in for x. Negative 3 squared is 9, so we know that our L is going to be 9. We're going to again start with this part. So I'm going to start with f of x, which is x squared, minus L, which we just decided was 9, and that's less than, and now here's where it gets a little more difficult because I didn't tell you what epsilon is, which means you must leave it as the symbol epsilon. And so our goal, whatever we're going to try to get again, what we want is x minus c. Since c is negative 3, that means we're going to try to get x plus 3 in absolute value less than, and whatever this is going to be our delta, and it's going to have an epsilon in it. So it might be like epsilon over 2, epsilon over 3, something like that. So our delta is going to have an epsilon in it. Okay, now that's the first twist. Now in here, we're going to say, we can factor that as the difference of two squares. And so now we're looking at that. Now, remembering where we're trying to go, we want to get to an x plus 3. So we want to keep this x minus 3. This x minus 3 is a problem. So we need to get rid of it. But we could, now it is correct, to split these things that are multiplying each other into their own separate absolute values. That is a true statement. There is equality between these. But I can't divide by this x minus 3 because for the wrong choice of x, that might be 0. So now is where we do this kind of thinking. We're saying we want x to approach negative 3. Now we're going to decide what we mean by close to negative 3. So I'm going to just pick one away from that on either side. So on either side of negative 3 would be from negative 2 to negative 4. So I'm just going to decide that. So I'm going to say for negative 4 less than x less than negative 2, then now I can claim that this x minus 3 in absolute value, the biggest that can be on this interval for these choices of x would be when x is negative 4. And if x was negative 4, then the absolute value of x minus 3 would be the absolute value of negative 4 minus 3 would be the absolute value of negative 7 or 7. Okay, now I've set the stage, so my claim is that I'm going to try to make here a chain of inequalities. So this that we're looking at on this interval, so I have to state this, and I'm going to just look at the values of x between negative 4 and negative 2, which is reasonable if we're approaching x equals negative 3. That's going to be less than 7 times the absolute value of x plus 3, which we are still trying to claim is less than, that's less than epsilon. Okay, that's the tricky part. So from here, now working with this, I no longer have that issue that I had before of dividing by something that might be 0. So now I'm free to divide that 7 over, and this then is going to be my delta. So remember, we're saying as x approaches negative 3, we're trying to find a value of delta. So our claim here is that if we want our curve to be, if we want to get the values of x that we plug in to be within epsilon of 9, we're going to choose the x values to be within epsilon divided by 7 of x equals -3. So see if I can give you a big picture. Now our x squared, here's our curve. So there's not going to be much scaling here, so be a little forgiving here. So there's our x squared, and I'm going to say right over here is our -3. And the claim is that's close to, yeah, I know I'm going to look at, but that's close to a y value of -9. So what we're claiming is that you can pick whatever you want for epsilon. So you choose what that epsilon is. Then given that epsilon, our claim is that if you choose the x values down here to be within epsilon over 7 of -3, all those x values will fall within epsilon of 9. That's going to take some thinking. See what you can do with that.